Hello, everyone, and welcome to this first lesson this morning that I'll be videotaping for the Math 112 core requisite classes in the fall 22 semester. I hope to be using this in future semesters, but maybe changing this as I improve the program. But perhaps I'll keep it. Maybe it'll work out well. So what we're going to be doing is you'll find that in Canvas, the same place that you're locating the link to this video, you should also find a page of notes. It'll be over several pages, and I'm going to kind of fill in everything. What I decided I was going to do instead of writing it down myself, and writing is honestly not the best. I would go ahead and kind of paste the information in there for you to record in your own notes. So I intend the purpose of this video to just be to collect what is the essential information on the material that we're going to be covering in chapter 3. And then in other videos, we'll look at how we do calculations in StatCrunch. And then in another video, we'll actually go through some homework type problems that you're going to encounter in your homework and show you how to utilize StatCrunch to calculate these things and answer the questions and do work as appropriate. So we're going to be using technology. Sometimes I'll go to my document camera also. So I have all kinds of tools available to assist you in filling out. So what I'd like you to focus on today is making sure that you have that worksheet that accompanies the videos here, and that you fill in the information into that worksheet so that when you're going through your homework, you can reference this as a tool. So let's go ahead. We're going to find the page I want to share here. I think this is what I'm looking for. And it is. Okay. So in chapter 3, we talk about 3 ideas as we begin to analyze data and begin to try to make sense of it. We look for measures of center if we're looking at quantitative data as opposed to categorical. If we're looking at quantitative data, we try to figure out what is the best approximation, what we would characterize as a measure of the center of the data, because it's more than one measure of center. The second thing we consider is how much variation is there of the data. Are all the data values pretty close to each other, or is there a wide variety in terms of the values we obtain, like where the smallest value and the highest value may be far apart, and there's a lot of values spread across the interval that's obtained, or are they much closer together? So we'll discuss that. And then the third one is the measure of position. So we're going to discuss the vocabulary around each of these things, and then we're going to talk about a number of calculations that have to be performed. And most of these, not all, but most are going to be done in StatCrunch. All we're going to do right now is focus on the notes of these, and then later we're going to actually do questions when we look at the calculation of these things. That'll be done in a separate video. And then finally, we're going to look at questions in the homework and see how we do StatCrunch and how we answer those questions, whether it's with StatCrunch or by hand. So here we go. So let's go ahead. So, and probably the most famous measure of center is what's called the mean. People outside of stats will usually refer to the mean as an average. However, and this will be a question that you're going to probably see in your homework, we don't use the word average in statistics. It's like a tisk idea. So go ahead and give the definition of mean. And that is a measure of center found by adding all of the data and dividing by the total number of data values. So let's say, when you have tests, if you have, 3 tests and maybe you score 70, 80, and a 90, and you want to know the average of those 3 tests are, you would take the 70 plus 80 plus 90 to get to 40. And then when you divide by 3, you would obtain an average of 80 for those 3 tests. Or, excuse me, I should not use the word average. I meant to say you have a mean test score of 90. Excuse me, not 90, 80. So, yes, be careful not to use the word average. In my class, I'm not going to refer to it too much, but if you ever find yourself at a convention with statisticians, if you want to have the glasses dropped and the gasps across the room, say average. Is a tisk word in the wrong. So there it is. So that's mean, and we'll look at how we calculate this in a little bit here. A median is another measure of center, and a median is sometimes used when the mean is not the best measure of center. Specifically, when we talk about the price of homes, like the center price of homes, we usually don't refer to the mean price of a home. We usually refer to the median, and that's because this will be something we discuss in some detail later. When we look at the price of homes, homes may have a certain lowest price that they'll go to. But the amount that they'll go up could be significantly higher, which causes the mean to not be a good measure of center because homes that are really, really expensive, it can cause that mean to shift upward. So a median is a measure of center that is considered the middle value when the original data are arranged in order from least to greatest, or backwards, like from greatest to least. But usually order data from least to greatest when we do this. So, all right. So another measure of center, although I have to honestly say that outside of chapter 3, we're not going to usually refer to the mode as something that constitutes a widely used measure of center. This is the value of data of a data set that appears the most frequently. So some ways you may want to remember the difference between these three, because you see we have another one coming up here at the mid-range. We'll talk about this in a moment. We have these three here: the mean, the median, and the mode. The median, like in a road, median appears in the middle of the road. So that may be one way to help you remember median. But just remember that the order has to be in data from least to greatest. The mode is the one that comes up the most. So the MODE is the one that comes up the MOST. And then the mean, I used to tell my middle school students when I taught the mean is, you remember it's mean because not only going to force you to add the numbers, but you have to divide by how many numbers we add together. Fortunately, all of these are values that I believe StackCrunch is going to determine for you. So you're not going to have to worry about this. I think mode may be the one exception to that, though. But we'll take a look and see what we get here. The mid-range is another measure of center. Again, once we get out of chapter 3, we're not going to see it come up much of again. So it's one of those measures of center, but it's not a common measure of center. And it's just a measure of center that is the value that's midway between the maximum and the minimum value. So let's say, for example, if your minimum value is 10 and your maximum value is 90, the midway between 10 and 90 would be 50. And then 50 would be considered the mid-range. And the way you get the mid-range is to add the minimum maximum number and divide by 2. Okay, and we'll go over the formula for that in a little bit here. Now, we have one more type of measure of center, which is called a weighted mean. And fortunately, this is something that Canvas calculates, otherwise calculation of this can be a little tough. And it's a measure of center that's calculated from frequency distributions. It approximates the mean of the data represented. If we're working with a frequency distribution like we work with in chapter 2, and we know, let's say, for example, there are 12 data values that fall between 75 and 124, we don't necessarily know what all of those data values are. We'll talk about theoretically how that's done in a later video, and then how we can use StackCrunch to calculate the weighted mean. Okay, so these are the 5 definitions which constitute the measure of center. Now, at any point of the video, if you want to pause it, if you feel like I'm going too fast, always just stop the video so that you can copy the definitions down for yourself here. The second set of definitions we're looking at is what's referred to as the measure of variation. And this is, again, how much, like we look at all the set of data, are most of the data values close to what we consider the center, or are most values far away? Or are they just kind of generically scattered all over the place with no rhyme or reason? So this is what we look at in terms of variation. An example of this, let's say, could be if you have a bunch of students taking a Calc 1 class at UC Riverside Monday, Wednesday, Friday, 9 to 9:50. If they're taking this class, if you look at their ages, the chances are their ages are going to be like from 17 to 19 years old. It's not likely you're going to have some, 40-year-old who works, overnight, going to take his morning class in calculus at UCR. I mean, I'm sure it happens, but it's not likely. Most of the students in this are going to be, just within maybe 1 year of each other. On the other hand, if you have an evening class in statistics, you can have students as young as like 16 or 17 from high school. And you could also have students up to their 40s or even 50s in a class. So the variation of the age of the people in like an evening class of stats, like our class, for example, you'd expect there to be a lot more variation in age than you would at like a class at UC Riverside that ran Monday, Wednesday, Friday morning, 9 to 9:50 a.m. So that's what we're talking about when it comes to variation. Range, it comes up here and there as a measure of variation, but it's not the one we're going to focus on for most of this course. But as we define range, that's going to be calculated by taking the difference between the maximum and the minimum values of a data set. Now, I mentioned before, for a measure of center, if we want the mid-range, we would take the maximum value plus the minimum value and divide by 2 to get the mid-range. But in terms of a measure of variation, range just simply tells us what's the difference between the minimum value and the maximum value. If, let's say, students are taking a test and the lowest test score, God forbid, is 10, and then the top test score is 90, that means that 90 minus 10 would be 80, so that the range of the test scores would be 80 points. So that's one type of variation. The standard deviation, on the other hand, is kind of the gold standard for what we're going to be doing in terms of work this semester when it comes to the topic of a variation. And it's a measure of how much data values deviates from the mean. And this will be something that I'll actually show in class when I talk about standard deviation, because I feel like the video is not going to do it justice to explain how it's calculated. But a standard deviation, roughly, not exactly, a standard deviation is roughly basically the average values from the average distance that all the data are from the mean. So it's not calculated quite that way, but that's a close approximation to it. But this is something that we're going to be using a great deal in class, and we'll be working with a great deal throughout the semester. Variance is simply the square of the standard deviation, which is not used in class too often. But if you just take the standard deviation and you square it, you'll obtain the variance of the data. All right. When we begin to look at variation, and we begin to look at data that falls under what we usually consider to be like a normal distribution, and we're going to talk about normal distributions a little bit each chapter until we get to chapter 6, and then we'll be studying normal distributions pretty in great detail for the rest of the semester. We have this thing that's called the empirical rule. I think I put a picture with us also. It's over here. And we talk about how data is concentrated. How data is spread. And what we say that when we take a better look at standard deviation, what we'll find is that when we define whatever standard deviation is for a piece of data, we're going to find that more information is closer to the center of data than it is further away. And when we define the standard deviation, we'll find that 68, which is just a little more than 2/3, is going to be within that one standard deviation from the mean. If we go 2 standard deviations out, then we include that original 68 plus an additional 27 to come up with 95%. So you add an additional 27%, that's going to be 2 standard deviations. And then if you take a look here, if to go from 2 standard deviations above and below, we go to 99.7 if we add 3 standard deviations. So it kind of looks like that. So we have this picture below here, so I want to give you an illustration of that. Okay. And this comes from your book, so you can find what this is. And what we're talking, what percentages these represent is these are the data values. Once we establish what, in this case, we're looking at the measure of center being a mean. In data that's normally distributed, the mean and median are going to be equal, but we really kind of focus on the mean in this case. So if we establish that data is normally distributed, and once we establish what the mean of the data is, we can determine that whatever the standard deviation is, we expect about 68.26 of the data values. That proportion of data values is going to be within 1 standard deviation of the mean. 95% of it is going to be within 2 standard deviations, and then 99.7 is going to be within 3 standard deviations. This is just a quick introduction. We'll talk about this in more detail as we do examples, and we'll certainly talk about this in class also. In terms of what I focus on for the class instruction, the definite focus is going to be on standard deviation, as that's a really crucial topic, and that's the one that tends to be a bit more elusive to students initially than other topics that we're going to be studying this chapter. So I want everyone to understand the significance of standard deviation, because having that understanding is going to make the rest of this course a whole lot easier. But I'm going to have you keep this here so we can refer to it later if you have any questions. So we have the first page of notes here done. We looked at measure of center and we looked at measures of variation. Now we're going to go ahead and look at measures of position. The Z-score is the most common measure of position. We're doing lots of problems related to this. Okay, let's see, copy this. And as far as the definition, oops, hang on. There we go. Okay, it's the number of standard deviations that a given value X is above or below the mean. And I have the formulas for this right here. I'm going to put these in. I should put this over here. There we go. And we have two formulas, one for sample, one for population. So we're going to take a look a little later at how that is calculated when we look at some example problems. We're going to talk about also the symbols here, and that's something we could probably come back to. There are certain symbols for mean, and we can introduce those when I go to the written notes. But within the sample mean, here the X bar is going to represent the sample mean, and then the letter S is going to represent the sample standard deviation. If we're looking at the Z-score of a population mean, we're going to look at this letter here. It looks like a U, kind of an M and a U, and that's actually a mu. And the mu represents the population standard deviation, sorry, the population mean, and then the sigma. This is lowercase sigma, a Greek letter. The sigma is going to represent the population standard deviation. So one of the things that we're going to have to do is sort out the differences between the different symbols around sample mean, sample standard deviation, population mean, population standard deviation. And you see the Z-scores are essentially the same kind of formulas, just depending on what kind of data you're working with, whether it's for sample, which is going to be most of the time, or population. Okay. So we'll come back to that later and discuss that for sure. A percentile, that's another measure of position. And when we're looking at the measure of positions, what we're essentially doing is we're taking a look at the relationship of one value and its position in relation to the rest of the data. And there are certain ways that we can look at it. So a Z-score kind of measures the distance from the center. A percentile is the measure of a location, the piece of K, which is which divides the set of data into 100 groups with about 1% of the values in each group, which doesn't make a whole lot of sense until we see that. This is as it comes in the book. Let's say, for example, if anyone has ever taken an SAT, you find maybe you're like in the 60th percentile. That means that of all the scores there are on the SAT, that your score is going to be 60% higher than all the other people who took the SAT. So that's kind of what's being said there. The calculation of percentiles, there are two types of calculations that are involved here. Stephen, grab both of these. Shoot. Do like, let's see. This is not. Yeah, I know the copying pieces here. Yeah, I'm trying to keep from having to write this because my writing is not the best. As for those of you who see my class, I'm sure you'll appreciate my efforts to not make me copy my notes here. Yeah, there we go. That is that C should be a B. Hang on, yeah, there we go. Revert to percentile to data value. And let me capture that formula down here. let's put this down as one picture for the future. And I'm going to explain what all these formulas are. Once we get to some examples that we're going to be doing in our home. So, and I'll be explaining this in the calculations portion as well. So we want to find out the percentile of a value X. We're going to take the number of values that are less than X, and order the data from least to greatest, divide the total number of values, and multiply by 100. That L is going to be a locator, and there's going to be a rounding rule, which requires to round this up. So again, when we do the calculations, we'll go over that. But here's just a reference of where the information is going to be. All right. So let's look at the next thing here. Quartiles. Okay. Quartiles is another measurement number. A quartiles is like the subset of a percentile, in that quartile can also be written as percentile. But like quarter one will be the 25th percentile. Quarter two will be the 50th percentile, known as the median, and then Q3 would also be the 75th percentile, kind of like 3/4. And a 5-number summary is going to contain these quartiles, so this should be something that you're familiar with. Unfortunately, StatCrunch is going to be calculating this for you. Go ahead and do that. And then the maximum is going to be the number 5. So we're going to take a look to see how StatCrunch is going to find that 5-number summary for us. This should be number 5. Just hold on. There we go. That's what I'm looking for. So it's going to be the minimum, the first quartile, second quartile, third quartile. Second quartile is known as the median, and the maximum. Let's see. One display that we can use to measure, show position, as well as showing kind of a measure of center in dispersion, is something called a box plot. And put the colon here. And we come up with the definition of a box plot. Again, a box plot is something that StatCrunch is going to do for us rather nicely. So, and this is a graph of the 5-number summary. And let's do here. So try this. All right, guys. So it's going to consist of 2 boxes between Q1 and Q3, and then 2 listers. And don't worry, we'll see pictures of this. Okay. The drawing of box plot we'll come back to later, and that's going to actually draw by hand in the notes here later. We do calculations. And finally, one thing that StatCrunch is also going to do, which is really nice, is it's going to determine outliers for us as well, which have always been difficult for a lot of students to calculate. The outliers are data values that are significantly higher or lower than the rest of the data. There is a place we come and talk about these generically, but when it comes to working and with box plots, there are ways we can actually calculate these out and find out what these are. So I'll put this here. Hopefully this works out. Yep, that copied very nicely. This is a kind of a quick formula sheet to show how these are calculated, which we'll probably show an example of in the calculations, but we're also going to rely on StatCrunch to do this. So it's my hope that when you come to class on Wednesday, or whenever I have you, if this is going to be used in future classes, that everyone will have these notes complete. And the portion of the notes that we're going to be doing here, these are actually going to be done on paper. So if you have these notes here, we are going to do these, but we're going to do these in a separate video. The purpose of the first video is to just cut down the major information required for chapter 3 onto a couple pages of paper, let you get these copied, and then we're going to keep referring back to these as we're going through the lesson here. That's our first lesson for today. If you have any comments on it, please share, and I'll be glad to look for any ideas for improvement. Thank you.